This is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
Hello, everyone, and welcome to the FRC Roundtable. My name is Scott Davis. I'm a mentor for Team 2052 Nightcrawler. And unfortunately, I'm flying solo tonight. We don't have any Nightcrawler students as a co-host, but I think I can cover this on my own tonight. I'm going to share my screen if I can figure out where that button is for that. So one of the things that we like to do in a segment every week is talk about what's on the wiki. So in tonight's wiki is going to be, here it is, share that screen. Tonight, what we're talking about that's on the wiki is something that just came up. Oh, can you guys see that? Show my screen. Yep, there we go. Okay, now can you see it? All right, excellent. So what's on the wiki tonight is something that came up this week. We just added all of our members to our website. And a part of that is we all know how to take photos, or at least we know how to take a photo, whether it's a good photo or not. That might take a little bit of training. But one of the things that we had to teach our students how to do was to crop photos. In order to crop those photos, we had to install some software. Photoshop can be a little bit heavy for installing, for cropping photos, just if all you need is a square. And so we use a program called Paint.net. And Paint.net is a freeware shareware program, and part of the challenge of installing anything that's free is all of the stuff that might come with it, like Chrome toolbars or some other utility often referred to as bloatware that might come with whatever it is you're installing for free, because that's how those products make money. We use a tool called chocolatey.org. This tool is sort of like NuGet Package Manager or NPM if you're a software developer that uses Node Package Manager. And what it does is it actually will install full-blown applications for you, and it goes through malware checks, and almost always, or I haven't seen one yet, that didn't exclude all of the bloatware. So the nice thing about Chocolatey is once you install Chocolatey, then you can install all these applications, a lot of applications, I shouldn't say all, with a simple command like choco install and paint.net. And that's what we put on all of our laptops for our media people, because while paint.net is a very simplistic program and not great for graphic design, it's really awesome if all you need to do is pull a square out of an image and then resize it. So that's what's on the wiki this week, is introducing chocolatey.org, which is a free application that we use to install other free applications. You can even create an install script, which our programming captain has done, and he just runs the script and it installs Git and the Git tooling and Python and VLC and anything else that we kind of like to have on our laptops. If it's a free program, there's a good chance that Chocolatey can install it. So that's this week's edition of What's on the Wiki. All right, moving on to our main presentation. Tonight we have Bob Atkins. Bob is going to talk to us about project management. Before we started the recording, I was talking to Bob, and I was shocked to hear how many robotics teams Bob is mentoring and has started. So I look forward to having Bob talk to us about that in addition to his presentation. So Bob, the floor is yours. Take it away.
Hello, how are you doing today? By the way, I am not a very good public speaker, just FYI. However, I always like to start out that way because that's who I am. But I'm here because I think I find this very valuable. So I'll share my screen, and a little bit about myself is, well, now it's not doing it. Oh, entire screen, window. Oh, there it is. Okay. A little bit about myself. I'm actually fairly new to FIRST. Kind of strange that, I worked for Sprint for years. and worked with a lot of the vendors that support FIRST. Never heard of FIRST until about 4 or 5 years ago. And, I guess the circles are tight. So basically, I've had 30 years of experience building in telecommunications, building cell towers and cable TV systems all around the world. So this is a little new, but it's, once you understand project management, it just kind of flows because you understand processes. So no matter what you do, building a car or building a cable TV system or building a robot, it's just process. So the what I did is I put a 10-week project together, but at the very end, I broke it down where you can actually consolidate this into a 4-week or 6-week, and that way you'll get a good idea of how that process works. No matter if you want whatever week however many weeks you want. One of the things that you have to keep in mind is the team itself, and your how many days you meet, right? So with that said, let me kind of move on here and let me see how this works here because it's not working the way maybe it worked like that.
Bob, I think you need to hit. There's a little present version down there on the bottom right by the slider. There's like an easel thing.
There's actually a little thing that's kind of maybe hiding stuff.
Oh, maybe. Anyway, I think you got to get into presentation mode in order to be able to just hit the space bar to advance if that's what you're struggling with here.
Yeah. There it is right there, probably. Well, it's not doing it. What the heck?
Do you see the slider down the bottom that says 70%?
Yeah.
See the icon directly to the left? That looks like a little easel.
Yep, right there.
Click that and see what happens. Does that go into presentation mode?
No.
Well, I think you can just click on the number, your second slide there, and it'll advance. So you might have to.
Well, that's what I actually tried, and it's not doing that either. So.
Oh my! Is the window froze? Can you scroll?
Well, let me see if I can actually just go to directly. Is that working?
Oh, there you go. Yep.
Okay, so I have to hit the icon itself. I can see. I'm no longer seeing you guys. I'm just.
Yes, that's hard if you only have one screen. Yep.
So so the first page, I kind of introduced myself a little bit and what this is about, just like I talked about earlier. The project initiation plan is week 1. You go to a kickoff. A reveal is, I find, the most effective, so you can kind of meet everybody, see what's going on, and then or at least have a meeting at a location convenient for your team. That way everybody can kind of meet and kind of strategize as the kickoff reveal goes into play. So one of the things is distribute and review the game manual. One of the first things I found early on, and you guys have more experience, probably have learned too, is the kids just simply don't read the game manual, and that can get you in trouble right away in the very early days. So I basically tell the kids we don't start anything until everything is read, and we have a little test afterwards to prove that we actually understand it. Organization, assign roles. Project managers basically have sub teams, mechanical, electrical, programming. If you're just a small team, which we were in the very early days, I had 5 kids. We basically just kind of, each one of us took a role and went with it. And then every day at the end of the day, we would actually come together and find out what we learned, where we could go. Establish communication channels. We use Band quite a bit. There's Slack channels, Discord, email, etc. But I'm finding that Slack and Band is probably the easiest out of all of them. I'm just not a real fan of Discord, which a lot of college kids are. Set up a project management tools. I like Basecamp. It's a really good free program for educators. So you can actually get onto it. You'll have to sign up. It's kind of like some of the CAD programs where you, as an educator, you can get into it for free. You just sign up and tell them who you are, and they'll approve it. Every year, I get a pre-approval on Basecamp. What I like about Basecamp is also it's almost an organization chart like a like Google or like Teams kind of type of thing. You can set it up that way. Define goal setting and time and timelines. Defines where you're going to be more successful. What the capabilities of the robots are going to be, awards, your outreaches, and so forth. Start defining those goals and setting all that stuff up. Develop a high level timeline, because in the very beginning, that timeline is going to change somewhat. Set up milestones so that you can actually know where you're going to be and where you're actually going to freeze the design and stop it and continue on. Schedule regular meetings, check-ins. This will determine timelines. Fewer days equals longer builds, and likewise, the more days will equal less time that's needed. The more senior teams is kind of fun, because your more senior teams will move at a much faster rate because they know what they're doing versus those younger teams. What I tried to do is I had 3 of the kids that were from other teams, and they had some knowledge. So I paired those kids up with some of my younger kids to try to keep that timeline going. This was actually new for me too, because a lot of the kids I've never dealt with inexperienced people. I've always had some pretty amazing people. So I had to learn how to teach kids at the same time of moving forward. So for me, that was quite an experience in itself. Start brainstorming early on with the robot and mechanisms and strategies. Evaluate what their ideas and budgets and flexibility. One of the things I do is I kind of run the program like a business. I use the new product as a product launch, so that the kids will actually have an idea of how a business would run versus just doing it this way. And it's kind of fun because the kids can actually start evaluating a budget and feasibility, impact, and all that stuff. They help me put all that together just like a real business would do. List the functionality requirements that you want to do on your robot. Do you want to use a tank drive or a swerve or mechanism? I know mechanism is not used that often for FRC. Any kind of manipulator, reach, limits, and stuff like that. Start defining all that stuff right in the very beginning. Then start designing and prototyping your weeks 2 and 4. Teams that I like to always start looking at this, teams that actually have a lot of equipment don't really have to worry about getting that order in early enough to get the equipment in so that you can actually start your actual design. One of the things I found for myself is I didn't know that there was some pretty heavy lead time sometimes, because a lot of the people bought the equipment and I had to wait for the equipment to be restocked. Things that the older teams don't have to worry about, because a lot of times they have that stuff on already in stock. Test and iterate prototypes rapidly. Start trying to figure it out, what you're going to need. The CAD and system integration. One of the things that, when I was in school, I'm an old guy, so we actually really had real drafting tables when I was learning how to draw and design. We didn't have CAD, so I'm still learning CAD myself. So I decided that with the kids early on, what do you do, with that? So we started doing sketching, and then my daughter came up with what she called cardboard CAD design, and we actually built, believe it or not, a full-scale robot out of cardboard with tape that you could manually manipulate the controls. And it was very effective. And in fact, the judges loved it because it was really out of the box thinking. But that was our way of CAD, literally. And so we were able to prototype our robot at a full scale, which really helped us a lot. And I've kind of suggested a lot of FTC teams, especially because it's really small robots, really easy to do. And it's an easy way to get right out of the box to do it. Start setting your deadlines and your freeze on your deadlines. That way you don't end up with what we call scope creep, which basically means that the scope of the work is creeping and advancing and taking more time than you expected. You want to try to avoid that very early on to keep your deadlines intact. Document and final design and create a bill of materials. Start doing that early on again, so that you don't end up with material delays because of materials not available at the time. Manufacturing and assembly, weeks 4 to 7. Again, like I said, I did a 10-week, but you can at the end of this, you'll see how you do a 4 and 6 week. Parts procurement, starts buying parts right away. Start, what I learned early on is I start guessing what I start needing very early and just start trying to buy some stuff. With me, I'm a fairly newer team, so there's not much. If I don't need it this year, I know I'm going to need it in the coming years anyway. So I start trying to get that stuff ordered. Any of your COTS parts and materials early on, like I said earlier, start tracking orders and management. I like to try to get my kids start doing inventory and tracking all that stuff early on. Manufacture custom parts using available resources. I didn't have and still don't have a CNC, so I have other teams that do have them, and I start getting them to help me CNC parts and 3D printing parts. I do have a 3D printer now. Any extra hand tools you might need and stuff like that, especially for newer teams. Start assembling subsystems and parts as they come available. That way you can start trying to get that stuff together. Especially like chassis and stuff like that can be easily done. Integrate your subsystems into the robot chassis. Address fit, wiring, and mounting issues as they arise. This is where that cardboard prototype came into play. Boy, it was really handy because you could really see where everything's at. A lot more even than a regular CAD or a drawing, because it was real life, where things you would miss in a CAD, you didn't miss in that at all. Aspects in assembly for accuracy and safety. Test fit and functionality and moving of all parts. Again, with that cardboard, we actually could manually manipulate the moving and functions of it, so it actually worked out real well. Electrical system. Start planning for that. A lot of teams, what I've noticed is they don't plan for the electrical system. It's kind of like an afterthought. Start trying to plan for that and routing it. And allowing that to maybe go through your tubes instead of around your tubes just makes a cleaner design. I'm a real advocate on a real clean, functional designs on that. In fact, I'm kind of a real stickler on it. Design and assemble the electrical boards and power distribution monitor. Again, that's make sure that's all integrated and fitted into the robot early on. Wiring and wire robot accordingly to FRC standards. That's something that was kind of new because the way we wire is a little different than the way I was taught. Even in automotive stuff, it's just done a little differently, and that's okay. It works. It's done differently. Develop and start testing your drive, your code right early on. One of the things that we did, we waited till the very end, and you can start your coding on especially on your drive stuff early, almost in the very beginning, because that what you need there. Implement autonomous routines and all the controls that you're needing. Integrate the sensors and feedback and loopbacks that you might need early on. Test all the subsystems with the software in the loop. Debug and start iterating as needed. Test, integrate, and deliver practice weeks 7 and 9. System integrate testing. you conduct a full robot test and on practice field. I always say I'd like to start driving early on. Again, this is some of the things that I saw earlier teams and some teams even do today. They don't start driving till later on. I personally think you start driving the chassis. In that way, especially younger team members can start practicing that really early on. They get a good feel of how it works, especially teams that maybe have gone from tank drive uh, um, a swerve drive. Big difference in there in how that performs. So a lot of the kids you can start driving that right away. This especially is needed for, like I said, newer drivers. Um, Identify and resolve the mechanical and electrical software issues. Hopefully there's none, but we know there probably will be some. Um, Start defining your mechanism and code based on the tests and results. Implement this faxes quickly and minor upgrades. Hopefully it's all minor. By that time, we should already be pretty well established what we need to do. Um, Select and train drivers and operators. Again, that if you start doing that earlier, you can start to see who can drive the robot best and where they can fit in better. Practice the game scenarios. You can even actually manually actually use humans as the robots and actually start executing some of this game strategies and how that's going to work. Final checks and documentation. Perform and comprehend inspection, weight, size, and safety. I find it last year the kids did a iteration of the robot, and I looked at it the day before our event. I looked and I went, "This isn't going to work." It literally was a half inch too big. Luckily we were able to just trim it down fairly easy. But had I not looked at it, it would have went into inspection, and we would have done that at competition, which is no fun. Prepare technical documentation, wiring, and backup codes. Real important there. I saw some robots a couple years ago that they put the robot on the field and they literally hadn't put code on the robot yet, and it just sat there. So start doing some of that stuff early on. Continue in driver practice with the finalized robot. The robot obviously will perform differently when it starts having weight and distributed on it. Pack your tools and spare parts and documentation so that you can have a go pack that comes away pretty quickly. Finalize and submit your award applications. Impact. Again, you can probably start writing a lot of your awards early on and at least getting outlines of what you're going to do. But this is the time when you starting to finalize all this stuff. Prepare your presentations and outreach. Have the kids start practicing talking together and working as a team in front of the judges. Post-mortem review. Allow the team to do debriefings to discuss how everything is working. Document and lesson and learn for future. And so celebrate. One of the things a lot of teams don't do enough, I think, is celebrate and recognize your success. Because the kids worked really hard. We were really focused on it, and they at the very end they was just all done. I think it's go out, have a dinner, go and have a pizza, watch a movie together or do something a little different. Just recognize and celebrate that as a team. Start planning your off-season stuff that's going through. Because now you have your robot. Look at what where you're going to be and start planning that and training that stuff out. Again, this is designed to help the teams navigate the complex, multidisciplinary, and fast-paced environment of FRC. I've been doing this a long time, and I have to admit, my very first time I did an FRC team was kind of shocking. I said, "You mean we're going to have high school kids try to accomplish this?" But it was, as you guys well know, that's pretty amazing. They performed very well. One of the things that I can do, if you guys want any kind of grant charts or any kind of meeting agendas and stuff like that, of course we can, I can help with that as well. And then I put a week 4 accelerated plan and a week 6 plan just in simple outline form on the next few slides. And basically, it's just basically takes what I just said and consolidates it into a more faster pace. But also, you have to realize, and you guys realize that the team, how they meet and their ability is going to perform, um, you know, change these timelines a little bit too. So that's basically it. Any questions?
Bob, you talked about so you put your slideshow was on a 10-week plan. Is that because most of your teams are competing in weeks 4 through 6?
Well, I figured I would put a 10-week plan together and then and consolidate into a 4 and 6 week, because that way you could see a slower time to a faster time, and how that process works, versus doing a 4 or 6 week and then having to show you the 10-week. I just went it backwards.
I see. Okay.
But you can see here, I'll go through that just a little bit. You can see the 4-week. It basically took what I showed you earlier and consolidates it into a much faster timeline. 6-week did the same thing. You can see this is much shorter the first week off, obviously, the 4-week. If you go into the next second week, does the same thing, and you can see it's a little shorter here too. And then once you start getting into the 4th week, you're finalized. In the 6th week, you can start seeing that it's starting to be about the same as far as your timeline goes. And then of course you're going into the final 6th week. It looks like I actually doubled a thing slide there. And then you finalize into the final 6th week, and you basically the same thing. So like I said, I just basically integrated the 10-week and went backwards versus going forward.
You mentioned 2 pieces of software that I haven't heard any teams. By the way, what state are you in, Bob? We didn't start that off at the top.
Sorry about that. I am the senior mentor for Pennsylvania, Western and Central Pennsylvania.
And you and I were talking beforehand. And how many teams are you working with, or are you leading?
Well, I am this year. Last year, I did 6 new startup teams. This year, it looks like there'll be 3 or 4 of those will actually come around. And I actually have 4 FTC teams and 8 FLL teams.
Wow.
So can you share with us, because a lot of us only mentor one team and probably help 1 or 2 other teams on a rare occasion, maybe not every week. How does that work for you? Give us advice about how to support multiple teams.
Well, it's all in time management. The teams that are actually school based, it's kind of easy because you can do that during the day. The schools or the teams that are do after school programs, you do those in the afternoon. So my days are Monday to Sunday every day. My hours are completely full. So that's how I schedule it all out. And then when I'm not there, I have other leads and that take on those roles.
And how far apart are your 6 teams that you're mentoring?
Most of them are within an hour drive. So I've got one that's actually pushing 2 hours.
Holy cow. That's amazing. You mentioned 2 pieces of software that I haven't heard other teams use. Band is something I've never heard of. I don't know has anyone on the call give you a thumbs up if you've ever heard of or used Band. That's not something that I had ever heard other teams using, and I will definitely be looking into.
Band is kind of a fun thing. It's actually a lot of school band uses it, and it's a real super simple program that you just basically, and there's other FRC and FTC teams that are using it, and you put your information in, and it literally tracks all that stuff. It's a one place shop and just like Discord or Slack or anything else. But I think it's a lot easier to use, especially if you have older parents. I find that older parents navigate to it really fast versus they don't navigate to Slack or Discord or other channels.
One of the challenges that we have in Minnesota is the Minnesota student privacy law that went into effect a couple of years ago. And Slack doesn't comply with that. And Discord is usually blocked in the schools for similar reasons. But additionally, it's a big time suck for kids who would have access to Discord during the school day. Our school blocks both Discord and Slack. We don't agree with the Slack block because the Minnesota state law says that you can't use it for academic purposes, but we're not. So we're using it for team purposes. Nonetheless, we can't get access to it inside the school. And I know that other teams have come up against that as well and have looked for or found alternate platforms. But Band's a new one for me. I had not heard of Band. I do know about Basecamp. I have used that professionally, but we've never tried to use that with our team. I'm curious if anyone else on the call give a thumbs up if you're using Basecamp with your team. Anybody want to share what you're using for both communication and let's get some kind of voices from the crowd here. What do you guys use for communications and sort of this project management, task management? Go ahead, Clay.
Nomythic uses Slack for communication, and we have a similar, but perhaps not as well regulated problem with Slack. Student email addresses won't work with Slack, but we have created, Nomythic's got a nonprofit now. We have email addresses for all the students under that nonprofit, or like at mythicalrobotics.org. And that gets us around that. It's a small enough school that I think the IT department just hasn't locked Slack out. And we use monday.com for project management. The name of the app is monday.com, which is a little maddening to Google things for it. But yeah, it's got a lot of different, it's really, really configurable, which is a plus and a minus, right? You can do too much with it.
Stacy?
Hi, 2472, we use Discord for communication, which the school does block, but many of the kids have it on their phone. So as long as you're not too far inward of the wing and all the concrete, you're able to get that. And then this year we started using GitHub for the project management, task management side.
Go ahead, Chris.
5464, we use Discord for communication and for task management. It's whiteboard and sticky notes. That was started last year. So that was our easing into the task management process. So.
Amanda, go right ahead.
Hey, 2530, we use Discord for our communications, and we have used various things. I can say 5 years ago, we tried Trello. I have no memory of that time, but I know that it was used by the students 1 year. I think that was right around COVID. And then we've since migrated. We need to work in this area. We used Google Sheets last year as a sort of an activity tracker, a job tracker that was kind of custom built into the sheets by one of our captains. And then this year they're looking at doing a Gantt chart type way of going through things. So, okay, the students don't like Trello. Well, maybe I wasn't the only one then. Okay, good.
I will say that 2052, we started a Scrum-based style of project management almost 10 years ago. And it was one of those science fair cardboard foldouts that we used Post-it notes on because everything had to go back in a closet. So we didn't have a board or anything that we could keep up. So we put our Post-it notes on our little science fair foldout, and then we'd fold it shut so they would hopefully not all fall off when we moved it, and then stick it in the closet. We've tried Trello. We've done monday.com. We did Monday because it was free for FRC teams, and then it was not free, but then at the last minute or maybe after the season had started, they gave us free access again. When it became not free again, we then migrated. I honestly can't remember what we went to after Monday. Trello was before Monday, and then Trello changed their policy and you only got one board, or you were restricted to how many members you could have. today we use Miro. One of the MillerBots mentors, Jess, I think, gave us a Miro presentation a couple of months ago or last spring on the roundtable. If you guys want to go back and dig through that, she was using Miro mostly for retrospectives, but I think they were doing task management in there. Our build team has decided to go back to a physical board. So we have since built a 4 foot by 6 foot bulletin board with wooden doors that actually close. I think it was Deep Space Field Element lumber from week 0 that got changed into a board that we could padlock and secure because our space is not our own space and other students in there during the day. And so the build team has decided to go back to a physical board this year, and the programming team, website team, and business media team are using Miro for our project management. Nobody's using Basecamp though. Nobody in Minnesota is using, nobody else on the call here is using Basecamp. Angela says we have physical Scrum board and a Gantt chart this year. I'm curious about the cardboard thing. Nightcrawler used to do what you called cardboard CAD. We did that for the first, I don't know, 8 years I was on the team, 6 years I was on the team. I'm curious if other people are bringing a ginormous stack of cardboard into their space at kickoff.
Yep. No mythic is. And cardboard and sheet, plywood and conventional lumber and, whatever we can hack together.
It's cheap.
Bob, can you share some of the successes that working with 6 teams, can you share some of the successes and the aha moments or anything like that cardboard got you that the previous process or CAD might not have?
Well, what I did was, to try to keep it together, I got the 6 captains, if you will, and they all got together and kind of worked together on a lot of that stuff. Kind of the 3 musketeers, one for all for one type of scenario, especially running. I actually literally brought 6 teams to the regional this year. So it was quite a challenge. And in fact, I don't know if I ever want to do that again. So, but it worked, and they all competed fairly well. But the success is they all built one robot, and then they all took that and kind of diversed from that. They were all kit bots, so it wasn't as hard, but they all had their own little uniquenesses to it because they made it their own. The nice thing is you're able to, run and understand how the wiring works. They can hand manipulate everything and actually push things through. I think the success really allows them to fully see, especially new kids, fully see a robot working within a week. It's manual manipulated, of course, but they get to see something really working. And now the other kids are starting to build the robot out and starting to design it all out. But I think they've really enjoyed it. Like I said, and the judges loved it. I mean, when my daughter called it, we use CAD too, but we use cardboard CAD, automated CAD. They kind of like that whole way of thinking because it's something out of the box. So the presentation went really well that way too.
And have any of your students graduated to another CAD like Onshape or SolidWorks or something
We started using Onshape this season. Yep. So it's and I've that's partially my fault because like I said I'm an old guy. I actually used we didn't use CAD. In fact it wasn't even introduced into school until like 3 years after I graduated. So
Angela, I think you had your hand up first.
I've always found that the cardboard or the just traditional drawing for prototyping works well for my students that don't have that strong CAD background because we take such a wide ability and age range. Some, the cardboard is easier for them to grab onto, some the drawing, some are crayon CAD, and some are, full on Fusion 360 doing well above my ability level.
Angela, I think you said Crayon CAD. I think you were talking about the Onshape plugin Crayon CAD. Is that right?
No, we have them using Fusion 360 just so everybody's on the same thing, but they're doing very simple two-dimensional CADing in Fusion 360 because not everybody is quite into the jointing and all the details. It's if they've never been on a CAD software before, it's a pretty big leap quick.
Sure. I'm going to share my screen here, if that's all right. Nomythic has, for the last 2 years, been using Crayon CAD, which is a plugin for Onshape that basically comes pre-rolled with a whole bunch of like subsystem primitives, and it allows you to sort of rough out a robot. Like each color here is something that sort of came pre-made, and we sort of slap it on. You might notice this looks a lot like a robot from this last year. And it gave it, you know, when the team was trying to decide on an archetype, right, like a general direction to go, we had 3 of them, and they sort of lined out the 3 major possibilities or the 3 variations on the overall theme and voted as a team on which one to go with. It was really easy, relatively speaking, to slap this together. We had some pretty proficient CAD jockeys last year, though. So
I think the thing that's nice about that is if you're, our team did this too. We had some adept CADers, and I think by the end of day 1, we had a rough CAD just as an idea. And I can't think two-dimensionally at all. And people start talking about put this gear here and this, intake there, and I can't see it. This is really powerful. I mean, but any of the things you're talking about, aside from drawing, can do the same thing, right? The cardboard can do it, whatever you have. I think different learners need different things. So it's great to integrate it all.
Clay, I got a question. So how does this, why is this more beneficial for you guys than straight up Onshape?
I think Amanda put it pretty effectively, or described it pretty effectively. Really, this is like your first pass, right? This is the napkin sketch. Hey everybody, we want to put the elevator at the front of the robot. We want to have this sort of like C-shaped thing with wheels on the top and bottom to intake the algae, and a chute, like a ramp on the back. But the ramp's going to drop down to let the this mechanism come through. Like communicating an idea, communicating what a thing is difficult. I won't claim to be good at it, but high schoolers are even worse, because one person's describing A and the other person's hearing B, and getting everybody on the same page in 3D space is tricky. And if you're trying to get everybody on the same page quickly, this is a great way to get there quickly. This thing has not been touched since week 1, right? Since early January last year. They put it together, they got the idea, and then exploded into doing the rest of the CAD and the rest of our design process. This was just like, hey, will all of our ideas fit? How big does our chassis need to be approximately? Like, what do we want this to look like? Does that answer your question?
Yeah, that makes a lot of sense. Thank you.
Yeah.
Angela, go ahead.
We find CADing like that, I guess we can work through and throw away ideas faster. They can fail faster.
I love that. I love failing fast. Right. Figure out if it works or if it doesn't.
That's right.
Or as soon as you can.
Bob, you said that, I think you said all 6 of your teams started with a kitbot. Is that right?
Yes. One of them was extraordinarily modified, though.
I'm curious to know what modifications they made, because I really enjoy last year going to the competition, seeing the kitbots, and then seeing how they had been changed. I'm curious to know what modifications your students made and how they came about making those modifications in terms of like their planning or their decision-making process of what to do and how to do it.
Right. What they did is they took the kitbot and they basically, it turned out to be very much like the Everybot, except instead of taking in and regurgitating the core out, they actually took it in and it rolled back in. It was just made instead of a really that whole big top superstructure that they had on it, they took it and only had a quarter of that size. So it intaked and outtaked in the same spot. And then on the other end of it, they welded a battery cage, and then that actually took the Everybot um, spike and just drew it in with a winch. And that brought it into in front of it. So it basically, if you looked at it, it kind of looked like a pickup truck, right? You had the front cab where the intake and outtake was, and then you had the back part of it where actually had the battery and the spike.
That's not only very clever, but quite awesome. I don't know that I ever saw an EveryBot modified that way to make room for a climber like that. Ours, we did build an EveryBot last year. We had some of our new students, when we ran out of things for people to do, we're like, hey, let's build an EveryBot or KitBot. And we put the KitBot together and we started talking about how could we make this thing climb, and no one, including the mentors, came up with anything like that. That's awesome. That's very exciting.
I wish I could take the credit for it. It was literally my daughter and the other kid. That was all their ideas. They came up with it 100%. In fact, when they were describing it, because it describes exactly like the EveryBot, I thought that's what they were talking about. But it was totally different. I said, guys, okay, because I kept on saying everybody. They said, no. I said, so we actually they had to sketch it for me so that I could physically understand what they were talking about. But it performed extremely well.
I'm curious to know, with your new students, how did programming go for your teams last year?
Programming is always tough because I'm not a programmer myself. I just don't have the patience for it. So, but it turned out okay. Between what we don't know, we have people that do know quite a bit, and we have that resource that we can go grab people. We have actually one of the guys is a programmer for a large company, so he whenever we need his help for an hour or two here or there, he happy to come in and help us with that.
So since the topic of our conversation tonight is basically keeping your build on track, your bot on track, for your teams, when did the programmers get the bot, and how did that kind of back and forth work between the builders and the programmers with your bots?
We started programming right away. Like I said, you wanted to get that chassis working. I mean, I can't stress enough. You should have a chassis working the first week. Really, honestly. And then once, because that way they can start driving and start trying to practice with that by itself. That was one of the mistakes we made early on, is just not having enough drive practice. And the kids, I don't think you can drive enough. First off, you start ironing out all the bugs just in that aspect alone. Parts start falling off, screws aren't, Loctited properly or not Loctited at all, or whatever the case may be. So you start finding those issues. So that's, when you start putting stuff on top of it, those issues are already gone. They've already been fixed. So I think that's really important, especially if you're going from tank to swerve. That was a huge thing that we did this year. That was probably the most challenging one I've done, trying to take that onto take that next step.
And what swerve kit did you use? That's a very common topic of discussion on the roundtable, is who's running what swerve. What swerve did you guys choose?
We used West Coast.
Okay.
That seemed to work. It worked out the best. We bought their whole kit, so it all came together. And then we used the what is that software that they partner with?
Did you use CTRE software?
Yes.
Okay.
Yeah. That helped a lot. Obviously, but once you put all the parameters in, it just uploads the software and builds the code. And what I liked about it, is the more you drive it, the more it starts tweaking the code to, because one of the swerve modules might not perform as well as the other one, so it starts tweaking to make them all perform well. So it's kind of interesting. Like I said, I'm not a coder, but I found that very fascinating, how all that integrated. They did a fantastic job of that.
I will say that over the years, I've done a lot of different things for Nightcrawler with our team, and I'm usually the mentor who's at the optional meetings helping with the programming. and I'm helping with the CAD crew and website crew earlier in the season and things like that. But I'm one of the few mentors that can get there for optional meetings. And I feel like last year was the best year we've ever had for our programmers. From our programmers' point of view, I feel like the culture within our team has really shifted where, especially last year, and who knows, we may regress, but I feel like last year our builders were thinking in components, thinking in systems. And so they built the chassis, gave it to the programmers. The next thing they did is they put the elevator on. And instead of going to saying, what can we stick on this elevator right away? They went off to the side, built the thing for the elevator, and gave the robot to the programmers. And the programmers had a day to make the elevator go up and tune the PID and all of those things on the elevator. And it was a really great back and forth that happened last year, where I know that a lot of teams and Nightcrawler had done this in the past, where the build team basically never stopped touching the robot until they said it was quote unquote done. And that can be a really hard thing to do, because like you said, you want to be starting program, you want to start code right away. I'm curious to know, for the other folks on the call here, what has been your experience between the robot handoff versus, touching the robot all the time for both build and for code? Does anyone have anything? Clay, you've already got your hand up.
Yeah, it's relevant. Two things that we did last year to try to get programmers a robot as soon as possible, or to stay out of the way of them having some form of robot. No Mythic is fortunate enough to be, we have enough resources to build, to try to build 2 robots. We usually build a practice bot and a tournament bot. Last year we built a disappointing practice bot, but we learned a lot of lessons as a result. But something that we did last year to ensure that the programmers got and had a chassis as much as possible was to do a lot of prototyping on a dummy chassis. I'm going to share my screen again here. And this is as simple as, hang on. This is an 80-20 robot chassis with, casters underneath it. And it's set up to be about the same height off the ground as our normal swerve setup. And with the 80-20 rails, it's really easy to just quick bolt stuff onto it and to loosen it and slide it back and forth and adjust it. It was affectionately known as the guillotine until we told them to stop calling it that. But this is how they prototyped how we were going to pick up algaes. And you can see we're controlling these motors with a little box over there. And I have the second version of that box right here, which is basically 4 thrifty throttles in one with little moving faders on it. So you can control a couple of motors all at once. And it's just an Arduino-based thing. I would say it got pretty reasonable use. It definitely meant that we didn't have to drag a programmer in to make a Falcon turn. We were able to run normal motors instead of using drills without having basically any robot there with us, right? We had a battery, a PDV, some amount of wire, and in this case, some Spark Maxes, and I think there's Neo 550s on there. But being able to control motors without the rest of the robot was a huge bonus, and it meant that we weren't taxing programmers with our petty needs to hey, can you come in here and turn on this robot so we can make this motor turn and see if it works. And it meant that they got to have the drive chassis because we weren't building on that chassis, or we weren't prototyping on that chassis because we had this thing. So, and this might be $100 worth of 80-20.
It looks to me like you're controlling those motors with CAN. Teach me, how do you get an Arduino to control Spark Max over CAN?
Yeah, so both Spark Maxes, so both CTRE and Rev, they're actually capable of running off PWM. And though that is a twisted CAN pair, it is just a 5-volt PWM signal. The current version is just using a hardware PWM output set up to the duty cycle range that FRC / the radio controlled aircraft community uses. Basically the way it used to be controlled. before CAN bus was implemented. And I've got a couple of safety features on here, like an arm button, and like as soon as you let go of this momentary switch, everything turns off, right? Like it's not fully implemented yet, but the idea is there'll be scene saving. So you could say, we figured out that running these motors, 50% this way and 25% this way works, and we'll save that scene so we can recall it later and show people. And because these are motorized or like flying faders, the little sliders will move when told to do so.
Oh, really? Wow.
This has been my overly complicated side project for over a year now. So
that's a very cool test board.
It's fun. I wanted to build a button board too. The students got to build one, and I wanted one too. Anyway.
Does anyone have any other questions? I've been doing a lot of questions asking about, please, if anyone else has something that came up that they have questions about, go ahead, jump right in. Amanda, go right ahead.
Hey, thank you. So it's been 2 years since 2530 had a week 1. Last year we had week 5 and 6, no, 4 and 5, 5 and 6. I can't even remember. It's a blur. Anyway, we were late. So we had a huge long time to build our robot. And it seemed like we needed that entire time, right? Because of course work expands to fill the time allowed. And this year we have a week 1. I'm kind of wanting to pick your brains about mindset when you have 2 comps and the first one is at week 1. Are you setting a goal? What is your goal that you're setting at week 1 versus if you have a second one, like, okay, what's your goal between that interval of week 1 and week 2? Are you predefining an outcome for week 1? Are you saying, hey, we're going to get as far as we can get, and we know we may not get the whole way, but we hope to get 70% of our functionality of our robot by week 1? Just kind of give me some wisdom on how you place your targets when you may not have everything you want at week 1. You have a later competition, but you're trying to maximize both the mindset and the goals for week 1.
Anyone want to take that?
Give me your secrets.
I don't have to call on you. If you got something to say, just go ahead and blurt it out.
I don't know if it's a secret necessarily, but with 2472, really been working with the students on kind of a modified agile process and getting them to focus on the bot. A couple of things that we can do. They prioritize 1 to 2 things maybe out of the game and try and have that ready for week 1. This year that was the scoring, and we were able to drive by week 3 at the practice field. For last season, that was probably the earliest we had ever been rolling and functional ever. And they continue to focus on that. We did attempt a climber. It didn't work, and they wound up scrapping that and then just focus on driving and trying to score because they were having success with that. So we just, like, you kids, that's what you want to do, then do with that, and kind of if it isn't broke, don't fix it type mentality. And last season it worked very well for us. Now I don't know what this season will bring, but trying to have them have expectations of what's reasonable to accomplish in the time that we have, and do a couple of things all the way instead of like 3 things halfway.
Chris, are you answering Amanda's thing, or do you have a new question?
Well, it's kind of related. It's not specifically answering it, but
go ahead.
Kind of circles around the design freeze, because I think we've struggled with designing for too long, and that ends up slowing everything down the line. So I was just going to ask how other people handle that on their teams.
Well, I'll share what 2052 has done in the past and some changes that the students are hoping they've asked to change our design process some this year. That'll hopefully maybe address both you and Amanda's question. So historically, Nightcrawler's always been in a week one or week two. Ever since it's my 11th year on the team, and we've never not been in a week one or a week two. And historically, the team has always said, what are the 3 things that we're going to do? And then what are our stretch goals? And what that results in is we go into week one with a really awesome week one robot. And then we go into week 5 with a really awesome week one robot. And so that generally creates a lot of challenges to compete well in week 5 when you've designed for week 1. And we always have good intentions of saying, hey, but after week 1, we're going to redo this or we're going to rethink that. And invariably what comes up is Easter and spring break and all the other things that get in the way of doing a lot of stuff between week 1 and week 5 or week 6. Last year, our students came back from week 1 disappointed from our week 1, the way that the robot performed. And so they asked for tons of optional meetings over spring break, around Easter and all of that stuff. And they convinced the mentors that we were going to start over. And we ripped it all the way down to the frame and left the elevator. And that was all that was left. And those students recatted everything. They built brand new mechanisms. We did a ground pickup. I would come in every meeting and somebody would have some part that they 3D printed at home, or one of our students had a CNC, a benchtop CNC at home, and they would come in with new parts and I would just shake my head of like, okay, good luck. I hope you can pull it off. And they did, and they did a great job. The change that we're doing this year as a result of our success last year, and again, this is truly, I think, only going to be possible because almost 100% of our leadership is back. We only lost one of our captains from last year, graduated, I believe that's right. And so our lead programmer, our lead build student, they're back. And so they have asked the mentors that we want to change the design process. We want to say that we're going to do everything week 1 because we think we can do it. And we've said like the same thing we said last year after week 1 of, okay, if you think you can do it, we're going to try to help you stay on track. But, that's your call. So Amanda, to your question is, historically, we've always said, what are we going to do week 1? And then we've made every attempt to try to improve between week 1 and week 5. But if you're going to compete if Nightcrawler is going to compete week 1 or week 2, we want to go in with what we hope is the best spot on the field for week 1 and week 2. We've seen a lot of examples of really great teams in Minnesota that tried to do everything for week 1 and it just didn't work out. But, it's just kind of the luck of the draw. You just never know what you're going to run into. That's going to cause you to get stuck and not get done. So my advice is you got to evaluate the students you have in your team, and they got to want to do the everything and be serious about doing the everything for week 1. Otherwise, I think there's a ton of great examples I can look back to over the years for Nightcrawlers. For Steamworks, we said we were only going to be able to do fuel reliably at the start of the match, and we weren't going to care about fuel after that. Deep Space, we did not fill anything above the lowest level scoring. We didn't fill the top of the rockets. For Rapid React, we had a student who spent a ton of time in CAD and a ton of time prototyping a rotary climber. And we finally just said, no, we just have to just climb the same way everyone else climbs with 2 sets of arms. And so we've got a really long track record of building a week 1 robot. And last year was the very first time we did significant robot changes between our first and second competition. So my advice is talk to your students, decide what your path is going to be, and then, try to get everybody to stick to it. Chris, in terms of deadlines, the best thing that we ever did, because we've used Scrum for years and we've talked about tasks and things like that. The best thing we ever did is on our whiteboard, we put down deadlines. Prototyping will be done by this date. Design will be finalized by this date. And then at the start of every meeting, we do sort of a kind of a kickoff of what are we going to accomplish tonight. And then at the end of the meeting, we do kind of a what do we get done. And when the students have to stand up and say, we didn't get finished with prototyping, and everybody looks over the whiteboard and sees that that was the deadline tonight, they don't want to do that. So they end up pushing hard to make those deadlines that the students agreed on of where we want to be on this date and that date. Invariably, those deadlines get pushed, but missing that by a meeting or even 2 meetings really lights a fire for students to make up the time someplace else. Clay, you get your hand up.
Yeah, Scott, Nomythic last year was where I think 2052 is this year, as far as having, all of the leadership returned last year, and the team was really strong. And they told us at the beginning of the build season, like, step off, we want to do as much of this work as we possibly can. We want to do the whole robot, do all the, we want to climb, we want to be able to put game pieces everywhere, we want to do autos, we want to use vision. And like, they had already proven themselves, they had already sort of demonstrated that they were up to that challenge. But those same students 2 years prior, this was before my time on the team, I believe it was Charged Up, where they built like a very narrow scope robot, and I think took it to champs. Like that may have been the year they won Impact, but they got selected for playoff alliances. I think this known as the Hoop robot. Like, it just like grabbed stuff and slid it around the field, and they did it really well because they kept it simple and implemented a robot they knew they could build. And then, of course, totally reinvented it for champs and built something that was, I gather, a bit of a nightmare. I wasn't there. But something that we did last year that worked really well was, I think it's easy for there to be, like, for lack of a better term, tribalism between sub-teams. If your team is big enough to have a programming team and a build team and an operations team, like, they spend all their time together and less time with each other. And we go out of our way to make sure that they're all like collaborating, that like programmers are sometimes programming in the build space, and there's a build person in with the programmers when they're working on the robot as a resource to explain how things work, and more or less just like developing a respect and a respect for the time of those other teams, right? Like, it's one thing to say, oh, we'll get, if the programmers get it a week late, tough. But like, we're all rowing the same boat, and making sure that they know that, like, oh, this, like, last year I heard a lot of talk, like, no, listen, we are giving them a robot today. I will stay as late as the adults will let me stay to make sure that this robot gets handed off to programmers by the end of this day, because they have work to do. And that was something that I think was a part of the culture, or became part of the culture, that like, we've got to keep our teammates on the, on track as well. It's not just like, we'll finish ours and once we're done, they can sort it out. Because we've had a history, or there have been in years past problems with, Bill just keeps wanting to tweak just a little bit more, or like, we're going to fine tune it just a little bit more, and then you guys can have it. And yeah, you can't even have it now, because the way that we're tweaking it, the robot won't drive. Sorry. But making those plans, setting those deadlines, sticking to them, policing feature creep, and like having contingencies. I think Nomythic unfortunately didn't climb at Duluth, and we had a sub team that was just pouring their hearts into making the climber work, and just were, they were troubleshooting the climber in the middle of Friday afternoon on the practice field still. And we ended up having, a decision was made, was like, we need to give time to the drive team to finish, to go do and like practice autos and stuff. So there was sort of a, we had a plan in place, for better or for worse, saying like, if the climber isn't working by X time, we'll have it for 10K. We got plenty of time to do it for 10K, and that sub team had priority. If no changes were being made to the robot unless they were like well out of the sphere of influence of the climber, right? Like, it couldn't mess with the climber because they needed time to do it, and nothing got added to the robot until it could be. Nothing got added to or changed on the robot unless it could be like validated off the robot, like on the practice pod or on the bench. Essentially, like, the robot worked pretty great all around, and we didn't want to break it. We didn't want to change something that made it less effective. It just needed more the drive team needed more time on it. We needed to make the climber work. So
I think Clay makes two really good points here. One is that breaking the whole robot for one mechanism or taking the entire robot offline for one mechanism is hard on your programming team. And so anytime you can avoid that, that's good. I also want to reiterate something Clay said. That robot, that charged up robot that Nomythic had, that Duluth robot was amazing. Everybody was talking about that robot, the entire regional, and all it could do was score cubes low. But man, it could score cubes low. It was an amazing, amazing robot. And I think you might have been ranked number 1, number 2 out of that regional, and that's all that robot could do. And yet it was ranked number 1 or number 2 in that regional. Our deep space robot could not score above level 1. We played every match in Einstein that for our alliance that year with a robot that could not score high. Your robot does not need to do everything in order to be able to be a good robot and make it to champs and even get on the Einstein field. So I think that's important too. I think students have to understand that doing 1 or 2 things as an excellent robot is better than doing nothing well. Maybe that's a great way to put it, is figure out what you can be awesome at. And if you can be awesome at everything, great. And if not, pick the things you can do well. We never trapped a note, not once in crescendo. We built a mechanism that we thought we could do it, but it was the lowest priority. Even though we ranked trapping a note for a crescendo really high on our must-haves, when it came down to it, it got scrapped on the floor, and we tried shooting the note in. And if anyone else has tried doing that, that the official field performed significantly differently than all of the practice field, including our own. Lisa says, has anyone had meetings exclusively for one sub team, like
yes.
Mechanical? Yes, I know some teams do. Nomythic, you guys do that, right?
Oh yeah. Yeah. We have a large enough team that's a meaningful number of people and a meaningful number of mentors can show up for just a build practice. And if it is the sort of practice where, hey, we're going to take the robot offline because we have to do this, we have to fix the thing that broke at the practice field. There's not going to be anything for the programmers to work on, and they're way ahead of us anyway. It's just the build folks there. And this last season put in a bunch of extra work to have. There's a deep freeze. We have a deep freeze in the build space and microwaves, and essentially, like, we were all the adult support team, both mentors and parents, were making and freezing meals and like easy to prep stuff so that these groups could eat. And somebody would be tasked with, putting the rice cooker on and defrosting a couple of bags full of curry or whatever it was. It was that they were in there 5 days a week from January to May, I think. Somebody was.
I'm pretty sure 4607 CIS lets each of their sub teams schedule their own meetings. And they got to work it out with the adults of who's going to be there. They got to work it out with the other sub teams of what days are you going to be in the shop this week. They very much, again, I believe they very much run their team asynchronously, where each group decides their own schedule. Now that can be tough on the adults, but they got to work it out with the adults to make sure somebody's there.
And Nomythic has 3 practices a week that are guaranteed, Tuesday, Thursday, and Saturday during the regular season. And beyond that, students, we had a sort of a prearranged, you have to be asking for adults for it at least a week in advance, right? You can't just be like, hey, we need somebody tomorrow, because nobody's going to be available. And you have to have a meal plan. Somebody's got to be either getting food or, making food from the freezer or whatever. But other than those 3 days where everybody was there, whoever needed to work was there, or they were at the practice field. Or
Bob, a lot of us have been around the block a couple of times here. I would love to know what you think was the most unexpected thing in your time as a mentor has been, especially starting so many new teams. What was that? What was unexpected? What was your aha moment? What do you think, those of us who have been around too much to think that it's important, that other teams that might be listening to this or watching the replay on this should know if they're on a newer team?
Well, I mean, you got to realize my rookie year was a week 1, so it was quite the challenge, and we went to Worlds. But it was I would say the most challenging thing is when you show up, and because you have a couple kids that are really dedicated, they're burning out. And I think trying to, I wouldn't say an aha moment, but one of the things that you probably need to back off on is to make sure that those kids that show up. I mean, there's times that my daughter and I were at the shop 2 in the morning, and it's like I'm looking at my watch going like, "Oh God, we're going to have to be here tomorrow again," you know. So I think pulling back and understanding that those are kids and telling them that they need to go home, I think is the most important part. That's something that I learned early on that I did not, as an adult, I'd push on 18-hour, 20-hour days. I have no problem with that, but they can't expect kids to do that. And so I had to back off and understand that.
Is there any, so you've heard the Minnesota crew here talk a lot tonight. Is there anything that you learned from us that you thought was interesting, or any questions that you might have from us that we should expand on?
No, I find this roundtable thing is fascinating. We don't do that, and I think that's something we should implement here. I think there's a lot of value to it.
Well, I'll tell you what, don't implement it there. Come join us. The roundtable is not it started out as a Minnesota thing, but we dropped the Minnesota from the FRC roundtable. So now we are just the FRC roundtable, not the Minnesota FRC roundtable. And we did that on purpose because we truly want more people to come in. In fact, I mentioned this before I started the recording, but check in the podcast statistics. We have more listeners in California than we have in Minnesota. So Californians, you're listening, and everybody else outside of Minnesota that's listening, join us live. Join us on the roundtable. Be part of the conversation. We'd love to have you. You can go to team2052.com/roundtable. There's a link there to sign up. You can get the link to join us on Google Meet. That's out there on the website too. Pop in. Don't feel like just because you're not from Minnesota, you can't be part of the conversation.
Well, I didn't want to just assume that.
No, and I need to do a better job of explicitly stating that. I'm gonna have to add that to the start of my script at the beginning of the call to say, hey, this is now the FRC roundtable. It's not the Minnesota FRC roundtable. So
there's also a lot of value in there's a group of people here, and the value is getting groups of people from other areas that share those ideas, because different ideas kind of come through together.
Right.
In fact, I'm talking to some FTC teams that were doing some of that in West Virginia and Maryland. We're looking at trying to get together and actually form a little consortium.
Sure.
That's multi-regional, which is kind of neat.
Well, I will say personally, this has been the reason why I keep doing this is because I think it's tremendously valuable, not only for me, but I've heard similar feedback from other mentors and students too. I don't know that we actually have any students on the call tonight. Usually we have a couple. I'd really love to get to the point where at least 50% students and mentors. We'll get there. Students, I assume, are probably trying to get their homework done. They didn't do the rest of the weekend. But you never know. We pick Sunday nights because it's the one night that there's usually, and I have to say usually because Inconceivable is on here, there's usually not a meeting on Sunday nights. And so it's the one night of the week where it's usually available for most people. I know Inconceivable is you guys stopped doing your leadership meeting at this time. I appreciate that, but
out of respect, true.
I'm going to have to, I'll just keep poking at you guys that I can't say that nobody meets on Sunday nights, because that's obviously not true.
We have a STEM Sunday. And
you do?
We what we do is we actually have the football game on. Mom and dad go and watch the game.
There you go.
We take the kids and we play with robots.
Now, what game? Are they watching the Steelers or are they watching the Eagles?
Well, it depends. It depends on what's on. Steelers were actually earlier, so before we actually had our meet. So we actually, I don't remember what they had on today. But it was, it works out pretty well. That way, mom and dad can go out and have, be fun and don't have to worry about the kids. Is FTC? I have a very, very young FTC team. so upper elementary and middle school. So mom and dad can actually have fun and don't have to worry about the kids. And it's worked out pretty well, and everybody can join. I mean, we have kids that's not part of the team that just has showed up one day or 2 days or one day a week or one day a month. So it's kind of works out. So maybe they'll actually start getting the bug and actually join the team. Some challenges with rural and economically areas is they don't see the value in this as much as we do.
Sure.
And so we have a hard time training the parents to know that they have some value. So one of the things is when you work, the guy that does a Sim Sunday, he played for the Eagles for 10 years. And he's a local boy that grew up there, didn't have any money. And when we first started talking to him, he said, "You're doing it wrong." He said, "What you need to do is tell mom and dad that that they can drop off their kids for free, which they don't have the opportunity, feed them." And he says, that works. So it absolutely has worked. It's a whole different focus than what we were taking before. And we said, that's the focus that we're taking. So and that's where STEM Sunday came around, where now mom and dad can be there, but yet not there. And so it's actually kind of worked out well doing it that way. It's a learning game. And the other aspect is the rural communities. They all think they're not smart enough. And one of the stories I like to tell is I live in a very, very rural, and there's less than 300 people live in my zip code. And so I heard there was this. I live in a valley, and valleys carry noise. And you hear all this grinding and in going on, and like any other nosy neighbor, you have to figure out what's going on. And so I drive down the road, and my neighbor has a tractor that's almost 90 years old, and he had broke one of the parts in the front suspension. Of course, you can't buy it anymore. So he has a block of steel and a vise, and he has his grandkids with him. And he has a hand grinder and a drill, and he's milling this part by hand. And I'm going like, dude, and he's the one that says, I know nothing. do you realize that skill? But they've been doing it for so long and so often. You hit it earlier, Scott. A lot of people, if you do something for so long, you think everybody knows it. And a lot of these people in the rural communities don't realize how much they really know. My daughter says the best. She says, if we can get enough rural kids, they kick butt because they're used to doing something with nothing all their life and making something happen out of it. I was, just recently I had a 6-year-old with an excavator digging a trench down the street. And I'm pretty lenient on that kind of stuff, but I don't know if I would have done that, but I came back and this kid had dug that about 150 yards trench with that excavator and was covering it up. He's 6. So, so the whole point of that, what I'm trying to go with, we just have to change some of our philosophies with the rural communities and economically challenged communities than what we're doing. I think some of the focus at first, unknowingly, is more targeting more of the affluent neighborhoods. And not purposely, they're not doing it on purpose. It's just, they're just out of touch. They don't understand it. Me neither, until I started getting into the community. It took a football player that made it out of the neighborhood to say, hey, you're doing it wrong. And then I had that dumb look on my face. It's like we probably all have had it, going like, man, that's perfect. And it has worked out perfect that way.
That's
anyway.
fascinating. I really appreciate you sharing that difference of approach, because that's so important for us to hear those different approaches. I love the idea of robotics tailgating too for the football game. Big fan of that. If I could get into my building on Sunday, maybe we would even try that. But neat idea. I really appreciate these neat ideas because it is definitely a different approach, and you don't think about those types of things sometimes unless someone slaps you in the face with, hey, you know what we learned? And that's awesome. Thank you for sharing that.
And that's what these roundtables are great for. I'm finding the value here is immeasurable.
All right, we're getting close to the time here. Does anyone have any final comments or questions they want to share tonight? Questions to Bob, questions to the group, anyone?
I guess I was sitting here while you're talking about rural teams not thinking that they could do it, that they weren't smart enough to do it. And I'm looking at you get on Statotics and sort by, top EPA ranked teams in Minnesota, and 7 out of 8 of them are not from either the Twin Cities Metro or Rochester. Right. There's Nightcrawler, Ultraviolet, Inconceivable, Oncobots. But like at the top of that list is Toolcats and CIS, who are not from the Twin Cities. And they can do it.
Yeah.
Probably got more know-how than the average, person walking around in downtown. So
They just don't know it.
Right. One of the just dominant teams for a long time, who unfortunately don't have a team this year, the Gators. I mean, they're up in Greenbush, and Greenbush is a small town. But the community rallied. A lot of technically, mechanically minded people jumped in, and you can 100%, you can do it. Bob, there were 17 kids in my high school. I grew up in a tiny little town in Iowa. I know on a farm. I know exactly what you mean when it comes to the fact that you don't realize what you probably already know how to do. All right. Well, with that, I think that's a good note to close on. Bob, please come back. We'd love to have you come back. Bring some friends.
I think this is a very valuable forum, and I'll promote it with people around here too.
And bring some students with you too. I try every week to get more of my students on there.
If you don't mind, I'll bring some FTC, some new mentors. I think there's some value because they'll learn, because there's enough similarities they can see.
Yeah, that's fine. The only thing is that if you're bringing kids, they got to be over 13. So if you're bringing FTC kids, they got to be over 13 because of the whole privacy laws and stuff. But we'd love to have you back, students and mentors. We'd love to have you back. And with that, I think we're going to close it out next week. I think we're talking about travel next week. We're talking about how teams decide who gets to travel and who doesn't get to travel. I think that might be next week. Otherwise, hop on the mailing list. I send out an email every Friday with what's coming up, the topic of the week, and you'll get noticed that way. Other than that, I hope everyone has a great week, and I will see everybody next Sunday. Thanks, everyone.
Thank you. Talk to you about.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.